Today we will learn about the problem based on self-inductance, and then we will discuss about the self-inductance of a long solenoid. So first we discuss some conceptual problem. If you have a coil or a solenoid whose self-inductance is given to you, say it is 4 Henry. The unit of self-inductance, remember, it's in Henry. Okay, 1 Henry means 1 Weber per ampere by 1 ampere. 1 Weber by 1 ampere means self-inductance of a coil is said to be 1 Henry. If a current 1 ampere flows through it and the flux linked with the coil is 1 Weber, that is 1 Tesla meter square. 1 Tesla meter square. Then self-inductance of the coil is said to be 1 Henry. So current flowing through this I, actually this I is varying. So di by dt, okay, I am writing in capital only. So di by dt is 2 ampere per second. 2 ampere per second. Rate of change of current is 2 ampere per second. And since it follows no sign, it means it is positive. So current is increasing with a rate 2 ampere per second. Now you are asked to find the induced EMF in the coil. Find induced EMF. Find induced EMF in the coil. How will you find it? Remember, in the previous lecture, I have given you the formula for the induced EMF. This E is equal to L di by dt. Okay? So mod of E is L di by dt. So L is how much? It is 4. Actually, you are finding mod of E. So 4 into di by dt is 2. So it's how much? 8 volt. 8 volt. But if I ask you what is the potential difference between the point A and B, then how will you find the potential difference? Actually, if current I is increasing, an increasing current is flowing, this I is increasing. And that's why we have taken the sign di by dt positive. Positive sign. So increasing current is flowing. So induced current will flow in such a way that it will oppose the growth of current. It will oppose the growth of current. So induced current should flow along this direction. And then induced EMF means you can consider a cell or a battery, and a fictitious battery is connected in the circuit. And what should be the terminal of the battery? Terminal should be positive side is this and this is negative. And then if this is positive terminal of the cell, then current from the cell will be delivered along this direction. Okay? So then VA minus VB is what? So that is positive terminal of the cell is coming first, and that's why VA minus VB is nothing but this is 8 volt. 8 volt plus 8 volt because positive terminal of the cell is coming first. That's why it is 8 volt. So you have calculated the VA minus VB potential difference. I am writing here also find PD, potential difference between the points A and B. A and B. I am giving you the shortcut method. So VA minus induced EMF across inductor is L di by dt is nothing is equal to potential of point B. Potential of point A minus potential of potential across the inductor induced EMF is equal to potential of point B. Then VA minus VB is what? This is L di by dt, and L is 4, di by dt is 2, 8 volt, 8 volt. So this way you can also find the potential difference between the points A and B. Now I am giving you the another question of same type. Now you have a coil and the current I, decreasing current, is flowing. This is point A, this is point B. Okay. Now you have to find induced EMF. L is, suppose this time it is 2 Henry, and di by dt is minus suppose 3 ampere per second, minus 3 ampere per second. If di by dt is given in minus, it means current is decreasing. Current is decreasing. So at the time of break of the circuit, current is decreasing with the rate 3 ampere per second. But at the time of make of the circuit, when the switch is closed and the battery is connected, then the current will be growing, and then increasing current is 2 ampere per second. So in that scenario, what is induced EMF? Induced EMF E is equal to L di by dt. We are finding magnitude. So L is how much? 2, and di by dt is 3 only. So this is 6 volt. But what is VA minus VB? VA minus VB. So this is L. VA minus VB is, how will you find VA minus VB? Now current is decreasing. So then induced EMF, induced current will be such that it will support the decrease. I mean stop it from decreasing. So then the induced current should also flow in the same direction, along the same direction. So what should be the induced battery or cell? Induced cell should be connected like this. Then positive terminal is along this side, then only this battery or cell will send the current in the direction of decreasing I, decreasing I. So since current is decreasing, so this will support this current I, which was decreasing. So then VA minus VB is what? L di by dt. So since positive terminal is coming first, so again it is how much? 3 into 2. So 3 into 2 is 6 volt. 3 into 2 is 6 volt. Or you can write VA minus VB is equal to how much? L di by dt. L di by dt. So then VA minus VB is L is 2 into dt is VA minus VB. If you move along this direction, 1 minute. Okay, take the snapshot. Take the snapshot. Yeah. Done. So again, if you are moving in the direction of current B to A, then VB minus L di by dt is VA. So what is VB minus VA? This is L di by dt. So then L, and you have to take the sign of di by dt. Since di by dt is negative, so you have to consider di by dt minus 3. So L is, this L is given to you, 2 into minus 3. So it's how much? Minus 6 volt. So this is VB minus VA. Now tell me what is VA minus VB? So that will be plus 6 volt. Plus 6 volt. Potential difference will be plus 6 volt. Okay. I can set one another example. If you have a coil through which I decreasing is flowing and the rate of decrease is di by dt is minus 4 ampere per second. L is suppose 5 Henry. Then how will you find induced EMF? That is L di by dt. So L is given to you. L is how much? 5 and di by dt is 4. Don't take minus plus sign. That is 20 volt. Now if this point is A, this point is B, now tell me VA minus VB. So VA minus L di by dt is equal to VB. Okay, then VA minus VB is what? L di by dt. So L is 5 and di by dt is how much? Minus 4. Then you have to consider the sign of di by dt. It is minus 4. So now it is minus 20 volt. So now there is a little difference between EMF induced and the potential difference. Potential difference between the point A and B, that is VA minus VB, is now it is minus 20 volt. Minus 20 volt. So if you see from simple method, so since current I is decreasing, so induced EMF, induced current will be produced along the same direction, along the direction of decreasing I. So induced current will be along this direction. So what should be the polarity of the fictitious battery? Negative, here should be the positive. Then only positive terminal will send the current along this direction. And then if I ask you what is VA minus VB, then negative terminal is coming first. So that's why it is minus 20 volt. That's why it is minus 20 volt. Yeah. Yeah. Then now we are ready to move towards the portion self-inductance of a long solenoid. Self-inductance of a long solenoid. Self-inductance of a long solenoid. If the inductance is given in millihenry, then 10 raised to minus 3, you have to multiply it, convert it into Henry. So 1 Henry is 1 millihenry is how much Henry? 10 raised to minus 3 Henry. 1 microhenry, so 10 raised to minus 6. So now self-inductance of a long solenoid. Self-inductance of a long solenoid. Now, here is your solenoid. Yeah. Solenoid of length L. Let L be the length of solenoid. length of solenoid, small n be the number of turns per unit length, turns per unit length, per unit length. So solenoid is nothing but collection of so many turns, that is conducting material like copper. Insulated copper wire is used, and then this should be in close contact. I mean, there should not be any gap between two turns. So they are densely packed. So this is the structure of solenoid. So if n be the number of turns per unit length, can you tell me what is the total number of turns in the solenoid if it has a length L? Therefore total number of turns in the solenoid of given length L is equal to n into L. Say this is capital N into L. And now if a current I is passed through the solenoid, then you know when a current passes through the solenoid, magnetic field exists everywhere inside the solenoid, except at the end point the value will be half of mu naught Ni. But inside the solenoid, magnetic field remains constant in magnitude as well as in direction. So a uniform magnetic field exists everywhere well inside the solenoid. So what is the magnetic field? When a current I passes through the solenoid, then magnetic field inside the solenoid, magnetic field inside the solenoid, well inside the solenoid, that is mu naught Ni. Say this solenoid has core as air or vacuum. So this is air cored solenoid. You may insert some ferromagnetic material also. Then it is mu r. The term mu r will also be there. Mu naught into mu r into n into I. So this expression we have already derived in Ampere's circuital law, magnetic effect of current. Magnetic field inside a solenoid, mu naught Ni. Toroid, solenoid. Are you remembering that solenoid magnetic field? So inside magnetic field inside a solenoid is given by mu naught Ni. The core is air or vacuum. Now, if I ask you what is the flux linked with each turn of the solenoid, so magnetic flux linked with one turn of solenoid. Remember, in assumption we are writing let A is equal to area of each turn of solenoid. So each turn is a circular loop, and this circular loop has magnetic field, you know, along its axis. So then magnetic flux linked with one turn of the solenoid is what? If it is magnetic field, then phi is equal to, or I am writing phi for total flux. Okay, so this is mu naught B into A, because flux is BA cos theta. So theta is 0 degree. Why? Magnetic field is along this direction, and the area vector of this turn is also along the same direction. So theta term is 0, BA cos theta. The moment you put theta 0, BA cos theta means B into A only. Magnetic field into area of one turn. So area of one turn, if R is the radius of solenoid, then you can write pi r square also. Okay. Lastly, we will put the value of area, which is pi r square. And then what is B? B is mu naught, and I will put it in the last. And say, if I ask you what is the total magnetic flux, total magnetic flux linked with the solenoid, with the solenoid. Since We have calculated magnetic flux linked with one turn. Since this solenoid consists of N into L turns, so flux, it is a scalar quantity. Their addition follows the algebraic sum. So you have to add all the flux. Means flux through first turn, second turn, third turn, fourth turn, and all the turns are identical. So flux, total flux is equal to this capital N into B into A. Because flux through one turn is B into A. So what is the flux through N turns? Capital N is the total number of turns. So this is N, B, A. Now N and B is mu naught Ni into A. You can replace this small n by capital N also. This is mu naught, small n is capital N by L, capital N by L into I into A. Now, once you get the flux, total flux phi, if L be the self inductance, if L is the self inductance of the solenoid, then L is equal to phi divided by flux per unit current. Flux linked with the solenoid divided by current flowing through it. So phi by I. Now this phi by I, if you take the ratio phi divided by I, you are getting mu naught N square A divided by L. So the final expression is L equals to mu naught N square A divided by L length of solenoid. Okay, the final expression is mu naught N square A by L, or you may write mu naught N square, capital A is pi R square if R is the radius of the solenoid. So suppose this radius is R, then you can write pi R square also divided by L. Okay. Now if I ask you, if you have a solenoid, and current flowing through it is 2 ampere and self inductance is found to be 4 Henry. Now what will be its self inductance if the current flowing through the solenoid becomes doubled? Now earlier it is 2 ampere, now if it goes to 4 ampere, what will be the change in self inductance? Yeah? What will be the change in self inductance? Who can answer me? Yeah? What will be the change in self inductance? Anybody else? If the current flowing through the solenoid is 2 ampere, self inductance is 4 Henry. Now what should be the current, what should be the self inductance if current becomes 4 ampere? Anybody else? Yeah, it will be doubled, because if I is 2 ampere, then L is how much? 4. If I becomes 4 ampere, then L becomes, yeah? So the correct answer is there is half. So there is no change in the self-inductance. Self-inductance does not depend upon the current flowing through the conductor. See, current flowing through the solenoid. See the last expression, mu naught N square A by L. Is there any I? No. So it is independent of I. If you increase I, automatically phi will increase, because increase in I will increase B. If B increases, flux increases. So I and phi are directly proportional. If I becomes 4 times, flux also becomes 4 times. Self-inductance is independent of the value of current flowing through the solenoid. So write it somewhere. L is independent, does not depend. Independent of current flowing through the solenoid. Then on what factor it depends? It depends upon dimension of the solenoid. Means the second factor is number of turns, total number of turns. If you have a solenoid having total number of turns, say 500. If you have a solenoid having total number of turns, say 1000, then L will be different. So L depends upon dimension of the conductor. Write it somewhere. L depends upon, the first factor is number of turns. The second factor is dimension of coil or solenoid. Dimension means area of each turn. So depends on R, and number of turns, that also matters. And then in other words, you can say, if you can write this expression in terms of small n also. So if you want to write in small n, then it is mu naught. See, this capital N square is n square L square. Okay, n square L square, then pi r square divided by this L. So should I cancel one of the L? So then n factor, n means number of turns per unit length. Dimension means cross section area. Dimension means length of the solenoid. That also matters. Radius of the coil. So these are the factors. Dimension. So dimension involves everything, that is length, area, and the number of turns means capital N or small n, number of turns per unit length. So these are the factors upon which self-inductance depends. Now remember, it does not depend upon the current flowing through the coil, current flowing through the solenoid, because L is phi by I. If you increase I, phi will automatically be increased, and this L will remain constant. Like R equals to V by I. If V is made double, do you think that R will change? No. If V is made double, I will automatically be double, and then V by R will remain constant. That is R, ohmic resistance. So similar is the case here. Okay, then we will solve one problem. Should I rub it? Take the snapshot. Take the snapshot. If you insert if you have a solenoid and then you have inserted a core other than air, like soft iron, if you insert a rod made of soft iron or any material having relative permeability mu r. So if this material has relative permeability mu r is relative permeability of the core material. For air or vacuum core, the formula is mu naught n square A by L. But for other material, if it is replaced by some iron piece or some soft iron core, then L becomes equal to mu naught mu r also. The mu r term will also be there. Capital N square A divided by L. Capital N square A divided by L. Or you may write mu naught mu r small n square L, then pi r square, you may write A also, area, that's enough. Mu naught mu r n square L A. So if you make the turns double, number of turns double, then what will be the change in self-inductance? If the number of turns are made doubled, what will be the change? It will be 4 times a square. A square is involved. So if it is doubled, it will be 4 times. If it is 3 times, then it is 9 times. A square term is involved. Okay? So I am giving you for iron core, some core material is there. In that case, self-inductance. Now if you have a wire of length L and you just bent it in the form of a circle. Now what is self-inductance of this circular coil? Find the self-inductance of this circular coil. Find self-inductance of the coil. How will you find it? So then you need to find R, radius of the circular coil. So how will you find the radius? Yeah, tell me. Then circumference 2 pi r must be equal to L. So what is R? This is L by 2 pi. Now if you pass a current I through the coil, then magnetic field at the center of the coil will be, so B equal to mu naught I by 2R. Mu naught I by 2R is the magnetic field at the center of a current carrying circular loop. If a current I is flowing through a circular loop of radius R, then magnetic field is mu naught I by 2R at its center. Now if I ask you what is the flux linked with the loop, then flux is equal to flux phi is nothing but B into A, since it has only one turn. So actually it is NBA, so N is 1. So it's only B into A. So B is now mu naught I by 2R. And tell me what is A? Area of the loop. Area of the loop is pi R square. Okay, should I cancel this R? Okay, now finally you are getting mu naught I by 2 pi, and then R is L by 2 pi. L by 2 pi. You should cancel pi. So it's mu naught I L by 4. This is phi. Now self-inductance L. I am writing this from here only. Okay. Then self-inductance, if it is L, L is phi by I. So what is phi by I? Phi by I. Mu naught L by 4. So this is mu naught L by 4 is the self-inductance. Mu naught L by 4. Yeah? No. This R will cancel out and this R is L by 2 pi. Okay, put it L by 2 pi. Right. Pi will cancel. So mu naught I L by 4. So then finally L equals to mu naught. This capital L stands for self-inductance. Small l is the length of the wire by which this circular loop is formed. Clear? Am I clear to you? Yeah? Tell me, am I clear to you? Okay, take the snapshot. Taken? Okay. Now moving towards mutual induction. Mutual induction. Mutual induction. Suppose you have a coil, mutual induction. Here is a battery and a key. And another coil is placed very near to the first coil and a galvanometer. This is galvanometer with pointer. Now, if you close this key, the moment you close this key, a growing current starts flowing through this coil. And so, magnetic flux linked with this coil will also keep on increasing. Because since current is growing, so magnetic field inside the first solenoid is also increasing. Consequently, the flux linked with the primary coil, what you called first solenoid, is also increasing. Since secondary coil, this is secondary part, is placed close to the primary coil, so some flux lines, field lines is also linked with the secondary, depending upon the orientation between the coils. So some field lines will also linked with the secondary. So there will also be a change in flux with the secondary coil. And whenever there is a change in flux occurs in a coil, takes place, an induced EMF, an induced current will flow in the circuit. And so galvanometer will show instant deflection. But the moment current becomes maximum in first coil, what will happen? That is, phenomena of self-induction will disappear. No induced EMF. So no question of change in flux in secondary coil. Now the current becomes constant. Once the current becomes constant, no change in flux with the secondary coil. So no question of induced current, induced EMF in the secondary coil. But if a current like alternating current is passing through the first coil, you know alternating current is varying continuously. It is not a constant current. It varies continuously with time. So if a varying current is allowed to pass through the first coil, that is primary coil, and the secondary coil is placed just near the primary, then this galvanometer will show you the permanent deflection. The thing is, if you place a galvanometer here, then its pointer goes like this. So if you have a varying current, so in alternating current, the current first increases, then decreases, then the direction of current reverses, goes to maximum and then decreases, finally becomes zero. This is one cycle. And in India, your household supply alternating current has frequency 50 Hz, means 50 cycles per second. In one cycle, the current reverses its direction twice. So in 50 cycle, how many times it will reverse its direction? 100 times. So the pointer, somehow it goes right, left, and this phenomenon will be so fast that for you it appears. But if you have a battery-like connection, the instant you press the key, you will find an instantaneous deflection in galvanometer, and after a few seconds, maybe 1 second, maybe half second, maybe 1/4 second, the galvanometer pointer again goes to zero. Because the moment current stabilizes in the primary coil, the deflection disappears. So this is a peculiar phenomena in which we are passing current through one coil and an induced current is produced in the neighboring coil. Though the two coils are not in physical touch. This is primary, this is secondary. So coils are placed at some distance, or you can place one above the other. But remember, the coils are made up of copper wire, insulated copper wire. So it doesn't matter whether they are in contact or they are placed at some distance. Their physical contact is not there. Then if you pass a current through first coil, say primary coil, an induced current will develop in the neighboring coil. This phenomena is called mutual induction. Transformer works on this principle only. So we are sending a current through one coil, and the another coil, secondary coil, is wound over the primary coil, and flux, due to change in flux in secondary, and induced EMF is produced in secondary coil. Now induced EMF, induced current produced in secondary coil depends upon the number of turns in the secondary coil. The more is the number of turns, the more will be the change in flux, because flux is NBA. More number of turns in secondary means more induced EMF. So if you are applying, suppose here 220 volt and you want 440 volt in secondary section, then you have to put the number of turns double. Suppose this is 100, then it is 200. This is 400, then this would be 800. Then if the number of turns in secondary is double to that of the primary, then the voltage becomes doubled. So sometimes we need a transformer, and you might have seen at your nearby house one transformer is installed by the government just to increase the voltage or to decrease the voltage. Step up, step down transformer. Two types of transformers are there. Later on we will study detail about the transformer. So first we write what is mutual induction. Write down the definition. The phenomena by virtue of which an EMF is induced in one coil when a varying current is passed through its neighboring coil. Neighboring coil. So this is neighbor of secondary. Primary is the neighbor of secondary. So you are passing a varying current through primary, and an induced EMF is generated in the secondary. And if the secondary circuit is closed, then induced current also. And if you connect a bulb here, the bulb will glow. Though primary and secondary are not connected directly, there is no physical contact, but sending current through primary will cause a glow of bulb in the secondary. Will cause the glow of bulb in secondary. So this phenomena is called mutual induction. Mutual induction. The phenomena by virtue of which an EMF is induced in one coil when a varying current is passed through its neighboring coil is called mutual induction. Mutual induction. Now mutual induction depends upon mutual induction. This phenomena is prominent. Mutual induction depends upon the number of turns in two coils. The word mutual is used, and that's why you need two coils. It's a mutual matter. It's a mutual conversation. Means two persons is required. But for self-inductance, self means only one. So one coil. Remember, mutual induction means two coils. There must be two coils. So the number of turns in two coils and the relative orientation between the coils. Suppose you have two coils. Okay, so this is one of the coil. The another coil is placed here. And if you are sending a current, increasing current through one coil, Okay, then magnetic field lines of this one will also pass through the secondary coils. Why? This face will be north and the field lines will go like this. Field lines will go like this. So this field lines form a closed loop. Closed loop. So if you are placing secondary, this is primary, this is secondary. So change in current through this coil will bring a change in magnetic field through the secondary coil. And consequently, the flux linked with the secondary, which is B into A. So since magnetic field at the place of secondary coil is changing, so flux linked with the secondary is also changing. And whenever there is a change in magnetic flux, an induced EMF or induced current, if the circuit is closed, coil is closed, an induced current will develop. Induced current is produced in secondary coil. This phenomena is called mutual induction. Yeah, got it? Am I clear to you? So what is mutual inductions? Mutual induction phenomena. This is mutual induction phenomena. Now, we will move towards, okay, take it, or it will be better if, uh, okay, take it. Taken?